Hopefully this will be a straightforward explanation about molds. So a mold for a tool such as the Safety Eye tool that we're creating is a complicated mold, and it has several facets to it, several things that we have to think about. So here's an example of a simple mold. Well, not a simple mold. This is actually a complicated mold, but a small part. But if you look at the part, you'll notice that it has a gap inside, like a slot, and then it's got a hole going the other direction. And this is a complicated thing to do in a mold because you have to have a moving piece, that a pin that comes in and after the mold goes together to make those extra holes. So the way a mold works is you've got two sides. So if we think of it as a simple mold, if we were going to mold a pencil, for example, then the person creating the mold has to take a very heavy, very expensive chunk of high quality steel, and using first he has to take my designs that are meant to create a tool, and he has to recreate a new design that inverts that makes it into a cutout instead of a creation. So he's got to go in and take my design, reverse it, basically put some time into changing that so that it's cutting out material instead of building up material. So he does that in his software to create the design that will create the mold, and then sends that to a CNC machine, which will cut that information out of this big chunk of metal. It has to be very hard steel, which is very expensive. It's a specialty tooling steel, of course, because it has to last many years and many cycles of being used over and over and over again. So he has to create the design for the mold and then CNC cut the design out of the steel plate. Well, if we're doing just a pencil, then you have a simple mold because it's just one thing stuck in the middle. You've got two halves of the mold because we have to get the thing out, right? So the mold has to have two halves. And so one part sticks in one side of the machine, the other part in the other side of the machine. And then also keep in mind that we have to have channels for the plastic to come in and for the air to go out. And so there has to be an input for whatever material is being injected and an output. So there have to be different channels connected to the design of the final part that you want for that input and escape. So with a pencil, it's two halves. You put it together, no big deal. But when you start getting something a little more complicated, he has to cut out all the words for sizing information, for branding and patent pending and any of that kind of stuff has to be cut out. And then for the shape of he's got to cut the actual shape. And then we've got two holes in this mold or in this part that cause a problem because we have one going one direction and another going the other direction. And then in the other piece, we have the center part that needs a partial hole. And then instead of a hole in the tip, it's got to have a little receiving divot to help hold the eye. May or may not be necessary, but that's the way the design is right now. So if we want to create that, he's got to figure out a way to get both the two holes in the parts in one direction and the hole in the tip and the divot. And so we've talked about how to place it in the mold, how to create the mold to make all that happen. But what this does is it creates a more complicated mold. Now instead of just two parts that sandwich together and then open up and you kick out the part, we have to have these two parts that sandwich together, but then we have to have a moving part called a pin that is going to come in from somewhere and go through. It's got to place itself into the center of the mold so that the part is formed around it, giving that extra hole. Okay? And so that adds a level of complication, more time, more tooling, and of course more expense to create a more complicated mold like that. And that's what we have with this example mold. They have the piece that kind of seems to wrap around something, so it's got a center slot there that slides over whatever this part is made for. But then in the end, you have a hole that goes the opposite direction, that goes all the way through the part. And so that hole, in order for that to be created in the mold, we have to have a moving pin. So over here, you can see the pin, and that's the part that when the mold is put together, that pin's got to move to be placed properly and be positioned in its proper place so that it will work, right? So it's a complicated mold. Well, like I said, if we do 2 different molds, then we've got to pay for that twice. We've got to pay for 2 blocks of steel, 2 sets of designing, 2 sets of tooling. All of that has to be paid for twice, and you're looking at probably at least $25,000 for a tool like this. There's another option that we discussed that would be cheaper as far as the mold goes, and that is to do what is called a family mold or a multi-part mold. With a family mold, what we've got is we can put multiple different pieces in one mold. So we could do a $30,000 mold instead of a $60,000 mold. And so if we do the small and the large the same color, because they have to be the same color, right? If we're using the same mold, it's going to inject material into that all at once and fill up all cavities. And so you can't have 2 different colors unless you do one set, one color, and another set, another color. So in order to get the large one color and the small a different color and have that consistent and always be the case, we would have to do 2 separate molds instead of one mold. And they would both be that complicated process, having to do a pin and all that stuff. So it basically doubles the cost of manufacturing. Once we have the mold created, then just to give you a view of how it works, it goes into this machine. This is an animated GIF here. And so it goes into the machine. The machine is this big, huge machine, 5 foot tall, 6 foot tall machine that pushes one part of the mold onto the other side. And then there's a hopper over here on the right that has the granules of colored plastic. And that is heated and pushed in and then cooled. And then the mold separates and kicks out the part. So it's quite a fun process to watch and to see it all, but it's very complicated to bring it all together and make it happen. And the biggest expense is just creating that initial mold there. So I hope that helps explain things as far as what it takes to make a mold for this part.